In this video, I will be discussing hypothesis testing and p-values. I will also be looking at the 2015 exam question to illustrate how hypothesis testing and p-values are used in practice. So our starting point is usually a sample mean as shown, x bar, and we use that sample mean to set up a 95% confidence interval between this lower limit shown here and the upper limit here on the right. And the idea is we're trying to figure out if the population mean is within those limits. Now, our starting point is to assume that it is, and we call this assumption the null hypothesis H0. And now what we do is, if the results from our sample back up our claim, well, then we make a formal statement to say that. One thing is we can't answer directly, we answer with a double negative. What we say is we fail to reject the null hypothesis. So what that actually means is our population mean is indeed between those two limits, the lower limit and the upper limit. So for all intents and purposes, we have predicted the population mean correctly using the sample mean x bar. So we fail to reject the null hypothesis. Now, the other alternative, of course, is that the population mean is outside those limits. It's either in the upper tail up here or the lower tail down here. Now, these are called the 5% level of significance because they're outside the 95% confidence interval. And if your population mean is in there, we say we reject the null hypothesis. We reject, in other words, the initial assumption that the population mean is between the two limits. Of course, if we reject the null hypothesis, that means we accept what's called the alternative hypothesis, which is the opposite statement to our null hypothesis. So for example, take a simple example where mu, the mean mark for a group of students, is 70%. Well, then that's the null hypothesis. The alternative hypothesis is that the mean mark is not 70%. So that's how it works. We can now illustrate all this with the 2015 question, as I said earlier. So if we look at this question, a survey of 100 shoppers. So that's our sample straight away. Our sample has a size 100. And when you do that survey, you find that the mean shopping spend was €90.45. So that means we can now set up a 95% confidence interval with these figures. And here's the formula that we always use for a 95% confidence interval. X bar plus or minus 1.96 times sigma over root n. So x bar, our sample mean, is 90.445 plus or minus 1.96, our standard deviation, which is given also 20.73 over the root of the sample size n, which is 100. And when you work all this out, you work out your lower limit, the minus part, and your upper limit, the plus part, up here, and you find out that your limits of your confidence interval are 86.39 at the lower end and 94.51 at the upper end. So the idea is our sample mean has allowed us to predict that the population mean is between these two limits. Now in part B, we're actually given what the actual mean is, 94 for the population, for all shoppers. And we can see straight away that that 94 is within those limits. So we bring down our confidence interval again down here, and you can see 94 is within what we predicted. So we have predicted successfully what the population mean is, 94. Of course, you can't say it like that. We say it using the language of hypothesis testing. So we set up null hypothesis H0. What does that say? Well, that says that the mean mark is 94. As I said before, you always assume that your mean is, that your null hypothesis is correct, that your mean is within the limits. Now, the alternative hypothesis H1, of course, is that the mean is not within the limits, that it's outside here someplace, it's either above the upper limit or below the lower limit. So since our null hypothesis turns out to be correct, we're inside, well then we can actually make our statement that we don't forget to answer in a double negative, we fail to reject the null hypothesis. That's the answer. That's what it's said to do here. State your null hypothesis clearly, your alternative hypothesis, and your conclusion. So we fail to reject the null hypothesis is our conclusion. Of course, there's an alternative way to do this using z-scores, as we've seen earlier as well, and it gives you the same result. There is your confidence interval between the lower limit and the upper limit. If we convert these to z-scores using the z-score formula here, you can get a z-score corresponding to our €94, and the z-score for that is minus 1.71. Now, when you're using z-scores, the way you test whether you're in or out, basically, is whether the limits turn out to be minus 1.96 and 1.96. As we saw earlier, they correspond to your 95% confidence interval if you're dealing in z-scores. So the minus 1.71 in this case is inside, so therefore, again, we accept, well, we can't say accept, of course, we answer in a double negative. We fail to reject the null hypothesis that the population mean is indeed inside the sample confidence interval. So two different ways to say the same thing, working in x values, or the normal actual values in the question, and the z values over here. Now, it turns out that there's even a third way to roughly say the same thing, and that's called p-value. So that's the last thing we need to talk about, and they are down here. So I will actually, I suppose, work it out here first, and then kind of we'll talk about the definition of what a p-value is. It's easier to actually do it in practice. So it says here in part C of the question, 2015, find the p-value of the test you just performed and explain what this value represents in the context of the question. So again, as we've seen here, we have a z value. So minus 1.71 is the z value. Now, if you go to your tables and work out the corresponding probability of being below that number in your tables, the probability turns out to be 0.0436. So in other words, there's a 4.36 chance of being below that z value. Now, the red area, of course, in these curves is the 5% in the tails. 95% is what's accepted in the middle here, but the 5% or the 2.5% on each side in each tail is the danger area marked in red here. Once you go outside that, you're rejecting the null hypothesis. But again, clearly, our minus 1.71 is inside. So it looks like we are predicting correctly what the population mean is. Then there's this concept of p-value. And to explain the concept of p-value, I'll just go back to the notes for a sec. The p-value, by definition, is the probability of obtaining hypothesis test results that are at least as extreme as the results actually obtained, assuming that the null hypothesis is correct. So what does all that mean? If we go back to the example, so 94 is the population mean, as we saw. We are down here. So this is how far out we are basically from the population mean. This is how extreme our answer is. And the word extreme is important here because if your answer is too extreme, that means you're in the red area. The red area is the total extreme you want to avoid. So the p-value is kind of a way of telling you how extreme your result is really. And when my result is at this side, but it's not far enough to be in the red area, well, that's a good result. And one last thing for p-value then is the p-value is how extreme your result is on both sides. So your result basically on this side, how extreme is it? Well, it's as extreme as that. Any result beyond that is more extreme, of course. And the same on that side. From there backwards is more extreme as well than the result you got. So what you do is you take that probability, which is 0.0436, and you double it. And the 0.872 then is clearly within the safe area as opposed to in the danger area, which is red. If you're in the danger area, of course, it's 5% altogether because there's 2.5% in this side, 2.5% on that side. So that's a total of 5%. It's called the 5% level of significance, or the 0.05 as a decimal level of significance, as it's called. And you want to avoid that. So the key thing in these questions is to get a p-value that is above 0.05, which means in effect that you're within the two limits.